Subject is sonar signal processing. So actually sonar signal processing we will cover mainly the tracking and estimation uh, related to the sonar signals and radar signals. So I follow these books or reference book. The first one is Fundamental of Object Tracking. This book is written by Chala, Morland and Muzaki and Evans. And then Estimation with Application to Tracking and Navigation by Ba Shalom, Rongley and Kirum Parajan. And then finally Advanced Signal Processing Handbook, Theory Implementation for Radar, Sonar and Medical Imaging. But don't worry about the medical imaging. This is just we can ignore. This is not our interest. So we just look for radar and sonar signal processing systems. The first book is actually written by my professor Dr. Muzaki. He was no more, and Dr. Muzaki was my PhD supervisor and advisor. He was working in the Hanyang University as a full professor, and he died in 2014 during my PhD. The course objective are to understand basic signal processing in the sonar and radar system, to understand the estimation theory, to study the target tracking algorithms, and finally you have to develop target tracking algorithms using sonar or radar signal processing. Okay, so this I designed the course outline like this. In the week 1 we will start with introduction to object tracking, where we will have to study about overview of real-time system and object tracking problems. Next, Bayesian reasoning with application to object tracking and recursive Bayesian solution for object tracking. Then brief review of probability theory. The probability theory is very important before going to estimation, because the subject is based on the probability of the object of the object existence, and then basic concept in estimation theory. Then this chapter will cover up in 2 weeks the state estimation in discrete time linear dynamic system, and then estimation for kinematic models. Then you will have a mid exam. After the midterm, you have to study about the computational aspects of estimation, then state estimation for non-linear dynamic system, then object tracking collector. This chapter will cover up in 2 weeks, and then again single object tracking collector based on object existence based approach. This chapter will cover up in 2 weeks also, and then practical object tracking, where you will develop practical object tracking, and you have to consider the practical implementation, and finally you will have a final examination. Let's start with the introduction of the subject with basic overview of real-time system and object tracking problems. So this is the contents, and this figure shows a overview of a generic real-time system and very simple block diagram. You can see there are 3 basic block diagram, like signal processor, data manager, and display subsystem, which is actually operated by some operator interface to communicate with the data manager. Here the transducer or multiple array of sensor or transducer. The multiple array means array of, it consists of array of sensors and transducer, like antenna, and which transmit the signal to the signal processor. The signal processor actually provide the mainstream signal, the mainstream signal for detection and initial parameter estimation. So here signal processor provide the mainstream signal for detection and the initial parameter estimation. Then data manager actually control the signal measurements from the signal processor, like it initialize tracks, it automatically maintain the tracks, and also it automatically manage and update the tracks um, based on the signal processing measurements in this block. So tracks are initialized and automatically maintained and updated in the data manager, and the data structure or the data of state um, transmitted to the display subsystem via the operator interface links between these two blocks. And here the user here the user can uh, see the output of the data manager and can receive the data structure and state estimation from this block to here at the display subsystem. So I have written each and everything in this slide, so you can read by yourself. So this is very simple block diagram, like the signal processor, data manager, which support data information processing functionality. So like it's initialize tracks based on signal processing measurements, and it's also automatically maintain and update the measurements and display subsystem through which the system operator can interact with data structure in the data manager to make the most effective use of the resources at his command. So these three blocks are consist of algorithms and processing architectures required for their implementation. The signal processor is the most important component of a real-time system, which incorporates the following operations. The first one is a multi-dimensional beam forming, match filtering, temporal and spatial spectral analysis. The first three operations are used to improve signal to noise ratio and the parameter estimation through spatial and signal processing techniques. And the other two operations are actually post processing scheme. The number four, tomography image reconstruction processing, and number five, multi-dimensional image processing. These actually are used for image reconstruction at the output, and the processing scheme associated with image processing applications like image recognition and feature extraction applications. So data manager has actually post-processing operation which form the functionality of the data manager of radar and sonar. In the data manager, we actually follow signal tracking, the signal information which is coming from the signal processor. As the data manager received the information from the signal processor, then it will initialize the tracks for motion analysis of any target or any object. So it actually uh, employ tracking and data fusion algorithms, and then image post processing and data fusion. Finally, data normalization. This data normalization operation in sonar and radar system is required to map the resulting data into the dynamic range of display devices in a manner which provides a false, constant false alarm rate capability across the analysis cells. This figure actually show the generic signal processing structure integrating the signal processing functionalities of sonar and radar systems. This consists of same blocks, but in detail, as you can see, the first one is area of signals like in the previous figure, and the middle block is a signal processing system, and the third one is active and passive passive sensor, and then the data manager is connected to, with active and passive sensor, and finally this is actually uh, the display. So the first one, the actually signal conditioning for array sensor time series. It consists of, as I already said, it can consist of an array of sensors or transducer. So the array shape follow the sensor coordinates like it is spherical coordinate or cylindrical coordinates or linear coordinates. Like for example, if you are working on spherical wheel or a robotic wheel, then the sensor coordinates will be spherical coordinates, and the array shape of sensor is also a spherical coordinate. In case of cylindrical coordinates, for example, your MRI system or like ECG system, like some medical side ECG system or CT scan system. So they use the sensor in the cylindrical coordinates, and for example, you are uh, analyze the motion of the object in the linear coordinates, then we consider the sensor in the linear coordinates. So this is actually shape of a sensor array, and then the band selection using FIR filter means it will select the specific band of signal frequency. Then the time series segmentation. So the output of this block is a continuous time series, and the sonar radar processing system in this block uses filtering for beamforming signal, like FIR filter and FIR filter adaptive beamforming. So as you know, beamforming uh, is we have to use the conventional or like FIR filter for beamforming, which enables the signal to be directed in the desired location, ignoring the interference in the signal. So like the sensor it actually follows the coordinates of the sensor of the beamform. So if we use narrow band weighting scheme, it sometimes the interference rejection, sometimes the interference rejection and the main lobe of the beam does not fulfill the requirement, or it sometimes often uh, fail to uh, fail to uh, uh, reject the interferences. So we use the passband FIR filter for beamforming using the sensor coordinates. So the output of this block is a continuous time series. It will enter into the passive and active sonar sensor or the active and passive radar sensor. So it used the uh, vernier band formation and consideration of time dispersive properties of medium to define replica, because during the transmission of the signal sometime loss the the signal losses and so due to some interference we lost the signal. So and also there are a lot of noises. So it uses the match filter. In the match filter, actually what happened, the replica of the signal medium propagation is considered to improve the detection and the gain. So it is written in the next slide. So as you can read from this slide, this is the first block, which actually consists of the time series from this receiving sensor array, and this dear special the initial spectral Fourier transform, the selection of single frequency band of interest via band pass FIR filter and downsampling. The output of this block provides a continuous time series at a reduced sampling rate for improved temporal spectral resolution. For the area of sensor and area shape estimation or sensor coordinates would be required to be integrated with the signal processing functionality of the system. So the other blocks the sonar and radar system deploying the linear, planar, cylindrical or spherical arrays is beamforming. Means the signal beamforming may be the linear or planar or cylindrical or spherical arrays configuration. Then in this block, as you can see, the FIR or conventional beamforming, they are used in the multi-dimensional array with these configuration, and the output of this block provide the continuous directional beam time series by using FIR implementation scheme of the special filtering. So the input to the block titled passive and active or continuous beam time series, which are outputs of the conventional and advanced beam formers of the previous block. The block title active includes a match filter subblock for the processing of the active signal. So in the match filter, the replica of the active signal considered in order to improve the detection and the gain, and the subblock of linear or bandwidth formation, narrowband analysis, and the broadband analysis include the final processing of the final processing step of temporal spectral analysis for the beam time series. Now the other block, data manager and the display subsystem. This includes the post-processing operation for radar and sonar system, like normalization, signal tracking, localization, and data fusion and classification functionality. Like here, this block actually propose signal trackers and target motion analysis, image post-processing, normalization, normalizer, and o-ring, and display system. So data manager actually consists of a few blocks, block diagram or operation, like uh, this the middle system, middle block is a controller, multi-purpose multi-processor controller, which automatically detect the measurements and the object, the information database, your data information database, and processed information display. Here the operator actually interface between the process information display and the tactical display, and then localize and tracks and tactical database. Tactical, what as you know, the tactical is the is a map uh, that used in the navigation map where the we can see every object in the display. This is actually the display, and before the display there should be a database of navigation or surveillance region. So the schematic diagram for the generic requirements of a data manager for the next generation real-time DSP system. So let us examine the levels of information required by the data management of sonar and radar system. Normally for sonar and radar system, the processing and integration of information from sensor level to a command and the control level include 5 distinct processing steps. These are the 5 processing steps from the sensor level to a command or control level. Number one is the navigation and the non-sensor array data, then environmental information and the estimation of propagation characteristics in order to assess the medium's influence on sonar and radar system performance. Signal processing of received signal processing of received sensor signal that provide parameter estimation in terms of bearing, range, and temporal spectral estimates of the detected signal. And then finally signal following or signal tracking and localization that monitors the time evolution of a detected signal estimated parameters. So first one is a navigation. The uh, navigation or the navigation database or tactical database or information database that is a non-sensor array data. And second one is information about environmental. That is what is signal medium, what is signal medium characteristics, and what the signal, how signal interference or how signal influence in the sonar and the radar performance, how it affects, how the signal medium affects the effects in the sonar and radar system performance. And then the signal processing that provide parameter estimation in terms of bearing, range, and temporal spectral estimates. Finally, the signal tracking and localization that monitor the time evolution of detected signal estimated parameters.